how you got yours. Can someone tell me one of the zeros on the x plus 3 or the x minus 2? 1, 0. Not for this guy, just for those two. What are the other guys? Oh, the zeros. Today's Wednesday, they did on Monday. No, it's a number. The last 0 is the same 2, but the opposite sign. They'll ask for it to be in parentheses.
Oh.
Yeah.
That's why I got it wrong. You put an X on it. You didn't put a question. You just lost it wrong.
On the very top of the front page, the very last one you have is a question mark below that 1, which is like, I don't know if you got close enough. Hey, someone tell me a second 0 for the 3. Yeah, -3. -3. Y comma 0 because they're x-intercepts. So when we write x-intercept number and 0. This is why when I give you the B version, they hadn't really, in our work, we didn't get a parenthesis or a factor just means they multiply by each other, where it had 2 numbers inside. At least I don't remember that. But here's how it begins. To get that 1, it begins with with that 1, same 1, opposite sign. The question is, what do we do with that 2? Anyone know what to do with the 2? There we go. I know what you're thinking, but no, not in this case. Good answer. This 2, if they ask you to find it, you put it below the 1. Number that's by itself goes first like normal. The second number goes below, and voila. Look how easy that is. There's the answer. Those are your 3 zeros. This solve and linear factors, find all the linear factors. The way they ask the question, actually, in my opinion, is incorrect. These are linear factors. Hey, Thomas, how do you know they're factors? Like, what else would they be? They could be zeros, or x-intercepts, or solutions, the red writing. So when they ask you, hey, find all the linear factors, you're like, duh, there they are. A factor is anything in a parenthesis already. So if I were talking with another mathematician who wrote this, I would say, well, you probably should have asked for the zeros or the x-intercepts, given the factors. The inspection is, okay, look at it and write it below. Last thing I'm going to write on this, I'm going to leave it. While I'm doing this other part, technically get the answer to this one, or to all of them. This is the way you technically get the answer. You do x plus 3. I'm going to do the x plus 3 one. You can sign in if you're taking tests, take them, of course, the test center. And then if you do, if you set equal to 0, that's actually the question you're being asked. Hey, Thomas, if I wanted this whole thing to equal 0, what are some x's I could put in here that when I put in the x and multiply it out, it'll make the whole right side equal 0? The real other question would be like, why do you guys even care about that? Why are you even asking me that? Technically, the answer is, if you were making a roller coaster, you're an engineer, and they say to you, hey, what kind of roller coaster you making? Oh, this one's going to be like looping like crazy. Kids are going to be like dizzy. They're going to be like throwing up on each other. They're going to be throwing up on each other, whatever. But they got to get off sometime, right? You got to get off the ride. So where do you want them to get off? Well, they can, like, at the top, and that doesn't even make any sense. Basically, you can get on right here, let the ride go, and then get off here at the end. So that's going to be hard, because then they have to walk all the way back to the beginning, so somehow make it loop back around to the beginning. How about that? Well, math talk for where are they going to get off is, hey, where are the zeros going to be? Where are you going to put the first 0 and like the second 0? Well, the first 0 can be here. We can leave it on there. And then from there, like we'll back it up. Like we'll take that thing and like tick, 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 tick. I don't put my hands up because I don't want to die. So we'll do. Raise your hand if you put your hand up on roller coasters. Crazy! You can hurt yourself. Way to go, Marcos. Don't put your hand up, man. You might die. All right, so tick, 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 tick. The thing goes underground. Yeah, baby. Then bring it back all the way right here. Then do a loop, do a loop, do a loop, do a loop. Whoa, then bring it straight back down, like vertical. Whoa! People with their hands up, let them fall out. then take it back. Tick, 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 tick. Ah, that was me. Let's do it again. Well, all of that is what these zeros are. Now, we don't make roller coasters, so they just say, oh, just get the zeros. But really, that's kind of what they're doing it for. Someone needs to bring a diagram so that you can have that ride. Where do you get off the ride? You get on right here. Get off here and you just walk back, whatever. Some rides bring you back to the same beginning point. You've been to, what's that place? Legoland near San Diego. I went there once. You get off at the same point. So they only have 1 0 for their Legoland roller coaster. All right. Let's see. Oh, what was I saying? To technically solve these, you write out this equation. When you solve this equation, you wind up with x is equal to a negative 3. To make this bubble equal 0, if x is negative 3, fine. This whole thing equals 0. Negative 3 plus 3 is 0. Here's the one that some people are going to miss. This 2x minus 1, it's a whole crew of water, dude. They drink so much water, it's like crazy. I mean, it's good for your body. 2x minus 1.
Wait, so Thomas, all we're doing is just finding zeros?
For this one, yes.
That's all?
That's it.
Oh my god, I'm so confused with that.
I know. I know. I wish I was here. Because I would say, hey, on the last page, make sure you just find the zeros.
You need to talk to Corey.
Well, he's a biology dude, and then this math. Yeah. And he went to options. I didn't know he went to options back in the day. Yeah. I don't know which center. To get this answer, watch this. Step 1, add 1 to both sides. That'll give you that that positive one. Remember the first one that goes on the top? Watch how the 2 is going to get on the bottom. To solve for x, I'm going to divide by 2. And voila, x equals a positive 1/2. Now, because I know I'm a math dude, I've been like doing it, I'm a story dude, I'm a sports dude, and I like being a math dude because it makes me special because there aren't a lot of math people around, and I look regular. See me? Just a regular dude. And I want to represent math people that way. Some math people, they look like strange a little bit. Nonetheless, notice the positive 1/2. This is right. And all it means is this. Hey, how can I turn this thing into a 1? I mean, into a 0? If I could chop that 2 into a half, like chop half of the 2, make it a 1, then take away 1, and I wind up with 0. All right, that's that for that one. I'm going to do mine on the board in this new era of technology. The test that some of you will take in the spring will be that, let's see, I don't know what the equation was. Y equals x to the 4th power? How do you get to the 4th power? How can I get up there? You do this a to the b, and then you put a 4. How do I get down from upstairs where the 4 is floating? You hit the right arrow, like arrow to the right, and it brings it back down. What's the next thing in line after the x to the 4th power? Minus 3x to the 3rd power. Hit that a to the b, put in your 3. Then right arrow, the right arrow, I don't know where it is on your keyboard, but what comes after that one? Plus 5x minus 6. Minus 6, where are you? Minus 6. How do I get rid of all of this? Like that? Now here's some beautiful thing. Here's what I got. Hopefully you have the same picture. If you're still working on it, work on it. I'll ask someone who can see it. Hey, how many zeros does this one have? I heard it. Say it again? Yeah, 2 zeros. This side of the room, you guys are responsible for one of the zeros. This side of the room, you guys are responsible for the other. Now, the good news is, to get your 0, you just hover your little thing over the 2 zeros. Remember, whenever you hear a 0 thing, ground 0, 9, 11, ground 0 is where you get off the ride. All these other dots, I think some people offered me some of these in one of the pictures. These are things that are happening, but some of them are, what's the word called, imaginary numbers. All right, would you guys like to go first, or would you like the second one? You want first? All right. You know it?
Well, it says it's negative 1.438.
Okay. And that was the one I could tell if you had that negative 1.438. This guy right here? Okay. Well, let me touch it. Hey, there it is. All right, this side one, what's the second one?
602.
There are your zeros. This crazy roller coaster, they start to feel like Superman, like, wow, whoa, that's crazy. Let's do it again. Yeah. Those are your zeros. Where are you getting on and off the ride? Again, since we didn't get to this one, but today I'm gonna have you start here to get that one out the way. I know, David, you need that one and one other. The way I've explained domain before, do I have the power to write? Yeah. The domain is, here's the graph. Tick, tick, tick. It has dots on it. I'm just following them just to make it more obvious. I'll stop there. The domain really says, if I were drawing a line down from the graph, if you were under the shadow of this flying machine in a sci-fi picture and it crashed because it got shot down by Will Smith and somebody, who would be affected by it? Where would it hit the ground? The domain is all about hitting the ground. It kind of has something to do with the zeros. Now, David, I'll have you say yours out loud because yours turned out to be kind of what they're looking for. Though someone else said it differently, and I think I may have given them a little love too. What did you say the domain was?
1913 to 2013.
Oh, that was it. You did it that way. Someone else says. 1913 starts here at 0, and it goes all the way till whatever this 100 date is. So I was going to give you credit for that 1913 because he's saying where does the picture begin and where does it end, and based on the time, it started in 1913. But someone else put from 0 all the way to 100. Who, are you out there? Whoever put 0 to 100? Oh, sure. Okay, yeah, I remember seeing that on there. The right, what's the word I'm looking for? The right notation for domain, even though I can give you a hard time if you just put the numbers, is beginning comma to the end. And your 1913, that would have taken it. Yeah, I took it. But in this case, usually it's whatever numbers they place on the x-axis. Here's the other question. Explain if any numbers are not in the domain. I tried to take your answer, but because it made sense, of the graph, and fully explain why it is. Well, let's find out what is the picture of. Because this question means like, okay, what are you guys even talking about? Years since 1913, the cost for 1 dozen eggs. So in the year 1913 at 0, a dozen eggs cost, and I can't see them on your thing. How much does a dozen eggs cost like that very first year? Does it show?
It's a little over 25 cents.
A little over 25 cents. The next year, let's let me erase some dots so I can see some of the dots they gave you. What is this dot to? I can't tell what. All right, let me say it this way. Each one of these represents a year, and on each year, you know how much the eggs cost in that year. Okay. So in the year 100, which is what did you have? 2013? Is that in 2013? Eggs cost about. Can someone say about how much they cost in 2013? I can't see any of it.
$2.
How much?
$2.
$2. Dozen eggs cost about $2 in 2013. And oddly enough, the conversation we're having is the answer to question number 3. So let me jump down to number 3. No, 2A, 2B. Describe how the inputs relate to the outputs in the graph of this real world. My other class, 2A, because we're doing vocabulary, they know whenever they hear input, it means domain, it means the x's. The outputs are, oh, this is theirs. The outputs are range, the y value. So they have to answer the question too, like what does this line represent? Let me ask, hey, what does this x line represent? Yeah, time, the years, okay. This y line represents how much the x costs. So over time, we know how much things cost. So here, describe how the inputs and outputs are related. If I were writing something now, I'd put something like a time versus cost. Given a time, what is the cost of the eggs? A dozen eggs. Given a time, what's the cost of the eggs, of a dozen eggs? And let's put the letter Y with the dozen eggs, so that you know, oh, this gives me the price of a dozen eggs, which I guess it just tells you on the Y. And put an X over time. Something about this bottom part. The middle part, and you kind of said it, and I liked it up. Middle part says, explain if any numbers are not in the domain of the graph, and fully explain why it is or isn't. That question really means, from beginning to end, what numbers wouldn't make any sense on this graph? Like are there some numbers that didn't even make any sense? Or if not, let's see, what numbers are not on the domain? Are there any numbers that aren't on the domain that you see? Here's a weird answer. Does anyone see -7 on the domain? No. Why didn't they put -7 on the domain, which would have been over here? Not why didn't they, but why is it -7 on the domain? Let's see what you say.
Because it's not on the chart.
It's not
It's not on the
started
chart?
from 0.
Started from 0. Okay. Both those answers are good. Get the thinking going. I think the answer key, which is really helpful to teachers, you guys should get one. If you don't know it, you can just like, what? Because this bottom thing wanted you to know the prices since 1913, they started the chart at 1913, representing it with 0. Any number before that is years before 1913, which the chart isn't trying to tell you about whatever happened before 1913. So you guys could put, you can put a negative number. Usually in real life, they never use negative numbers for your domain, your x-axis. And you can say it's, in this case, it's before 1913. Now again, earlier it's before 1913. It's before. Whatever, put before, that way some adults hate that abbreviating now because the text, they think young people's lives are going to be ruined. Of course, a long time ago, they thought rock and roll was going to do something like, it never is. Like rap music is going to make us be violent. I mean, I listen to, okay, I'm trying to think of some hardcore rap, but I didn't know when to say. I'll say Tupac like 30 years ago. In any case, it's before 1913. So here's the picture for that back question. So again?
So you can always put in -4.
Are these 5, 10, 15, 20? So each one of these is a 5. Can you? You can do that somehow?
Yeah, put in put number 3, -4. Then maybe 2x.
That is right there as a line?
Yeah.
And then it'll shorten the
Have like
picture?
a shape. No, it wouldn't shorten it. Have like a shape.
Okay. So the purpose of this, since I know that this is a 5 and that's a 5, and it would be enough. Basically, they would ask you what's going on with the picture between those two. So let me see what we got here. What is the domain of the graph of the cubic function? And I want you guys to feel this. Oh, I wish my other class, I won't talk about domain range that much here, but if there's one thing I could give young people, since they're always talking about domain, I would want you, whenever you heard that word domain, you're just walking on the ground. That's you. You're just walking on the domain. Domain is always about the ground level. So when they say, "Hey, Thomas, what's the domain?" They're like, "What if you were walking from like here to there?" Or like, "There's an airplane, the ceiling." What's the domain of the ceiling? Like the domain of the ceiling? Yeah. If you were under the ceiling, where does the ceiling begin? Like if it were to fall on you, like, well, the earliest it falls on me is right here, this wall. What's the end of the domain of this room? Well, it's the other wall. So basically, if I can measure how far it is from this carpet to the edge of the carpet over there, I'm talking about the domain. So when I say in this one question, hey, what is the domain of the cubic function? all I'm saying is now that we have this picture, what is the domain of this function? Well, they kind of told us in the question. They said it's from -4 all the way to +4. So that's the answer. How do you write that domain? You can write it with the brackets, that is -4 to 4. Or the other way to write domain, which I try not to show more than one way because some students are like, oh, do I do it this way, do I do it that way? Is saying all the x's that on the left of them you have a -4, and to the right of them you have a 4. That's what this is using inequalities, and you always use the less than symbol or equal to.
And that's what they put.
Yeah.
Wow, the answer was right at the
Yeah. Math is another language. Sometimes I'm watching, when I go to El Gallo, they have on the soccer game. They have it on because it's easier. This is the way you need to have heard, just in case they offer it to you that way. What's the next question to ask? Explain if there are any numbers that are not on the domain of the graph. Fully explain why it isn't. This is an odd one. This roller coaster, they told you that it goes from -4 to 4. So what numbers aren't on there? Well, 5 isn't on there, and -20 isn't on there. My response, though, would be because they told us what they wanted the restrictions on the domain to be. They told us how far they wanted that ride to go. And that one, I guess I'm not writing. Since, again, I won't need to do any of the B's, but just be aware of what they're saying there. What's the last question they asked on that one?
Describe how the input to the output of the graph.
Okay, yeah. In other words, this is a roller coaster. These are the inputs, your domain. If I ask you what's happening at 0 on the roller coaster, what would you say to me? Look at the picture of the roller coaster. What are the cars of the roller coaster doing at 0 on the domain? And it's on the board. What's going to happen to him at 0 on the roller coaster? Yeah. Here's 0. If I wanted to find out what's going on the roller coaster at 0, it's happening right here. So I would say he's going to reach a little dip or whatever, dip up. If I were doing my best back to that whole thing, you would have had 5 of these in a row. We've done 2 in class, and you've done 1 for homework. So by the time we have this conversation, you would have had it before. And that's what I'm saying. I think about doing your best. I feel bad sometimes for you all. But then I make myself feel better and go, well, they are at options, so they didn't do their best at regular school. So I guess we're equal. You know what I mean? You didn't do your best, I'm not doing my best. We have a good time, I give you some credits. Right, here you go. Woo! Good on. After they work for them. Here are your your zeros, -2, -2, 2, 2. What's my end behavior as x goes this way forever, also known as x going to -infinity. That y, he's going to go downhill. You see him going downhill? That y goes to -infinity. The other direction, as x goes this direction, as x goes to +infinity, the y, he's going downhill as well. The y, he's also going to go to -infinity.
How did you know what to put for y? I still get confused.
Okay. To know what's going to go for y, this m, this letter m, on the left side, when we're looking at this side of the wall, well, what is y doing? He's going down, down, down. Can you see him going down? Can you see this blue line going
So
down?
they're going to both be negative.
Yeah.
So if we're going up, it will be positive.
Uh-huh.
Oh, okay, because I was looking at where the dot is at 5, and I was like, why?
Yeah. And so that's the question with this one. They give you the zeros. They want you to write an equation for it. Here's what the equation can look like. Y equals, if I knew what the zeros were, there's a -2, there's a 0, and there's a +2. These are the zeros, you know how when they give us one of those things with the parentheses,
Oh.
Then we just go that line below.
And we just X.
Right. So they want you to go up. So if you were doing it going upwards, I'm gonna put a parenthesis.
Oh, wow, so confused on that part.
Yeah. Can someone say we'll go up in this bubble up here? It's the opposite
X
sign.
plus 2.
Yeah, x plus 2. Let me do the last one. How about the last one?
X minus 2.
X minus 2. The middle one? You can still say something. Go ahead.
X.
Yeah, it's just an x. Normally you do x plus 0, which is just x. They'll never write x plus 0, so they'll just put an x. So the order that someone wrote their answer in looked like this right here. They wrote it like x plus 2. They put just an x in the middle. Oops, and then they put the x minus 2. I hope it feels easy as I'm describing this stuff, and that you will realize, like, half of the time, it's not that it's super hard, it's just there's so much stuff to remember that's meaningless to you that young people don't even think of options because they never even ask people to do it. Alright, so here's what I'm going to do on this one. This one, I didn't want you to put in all the regular things, so this is degree, solutions, orientation. What's the other thing? Roots, also known as zeros. Y-intercept. This is the last hard one, the one when I back up. I'm just going to put it into the one. Oh yeah, and behavior. Did you pass that one? This section?
No.
You got one?
Yeah, I got one.
You went degree 3. Oh, you didn't draw anything.
Not in.
Yeah. You went degree 3, right?
Yeah.
Somebody did degree 6. Who are you? You did degree 6. Yeah. Do you know why you chose 6?
I just.
Yeah, because I know the degree, you just look at the exponent on the little
And
guy.
that's why I got confused too, because of the other root. That's what you just taught us right now.
Oh,
That.
that guy.
That's all it's like.
Yeah, but if in confusion, put something up. So imagine you're like, oh yeah, all right. So here it comes. So here's how I'm gonna do this, and I apologize for what I'm gonna do because you wouldn't know to do this. When it's time to sketch it, I'm just gonna make a big line. Sorry, little number man. All right, let's just do a big line. And I know they intended like these math people. They don't care about you all. They don't care. I'm like, oh yeah, we'll put like 100 little squares on there. Like, dude, you know they only need a -3, +2, and this -1/2 that they're not even gonna know about. At least instead of making 100 squares, like, I got 100 squares? Oh yeah, but your 6 thing, I thought that was cool. You did do a lot of stuff to go with the 6. In any case, the degree is, say the degree again, somebody?
It's 3.
3, the number of solutions?
3.
Always the same. Orientation?
Awesome.
The roots?
-3, 0, 2, 0, and then -1/2.
Yeah, sorry about the -1/2. I hope they don't do it on the next thing, and I don't even know I gotta do that. Hey, do you all do any of this in pre-calculus?
Are we doing this? Not really.
You guys, I think, do some of that unit circle stuff maybe at the beginning. Do you know what you're on right now?
We're on we're learning
I'm sorry, I don't think we're your mind. Let me take it out. Do me a favor, somebody with a cat. Oh,
we're still
okay.
learning about quadratics
Oh, okay.
and then vertical motion.
Oh, shoot. Because these are all linear factors. What do you mean linear? They only have a little 1 on the outside. To get the y-intercept, we just multiply the 3 digits across. Now again, if these were all whole numbers, would be fine. But let me see if anybody can do this. -3 times a 2 is a what? This is a y-intercept. -6. Anybody know what -6 times 1/2 is? I like when I ask that question, but now I can ask it the other way. That makes everybody just say the answer.
3.
Yeah, but y'all messed up the thing I was about to do. 1/2 times anything. Some people think, oh, I gotta multiply this fraction. No, 1/2 times anything always just asks the question, what's half of 6? Well, everybody knows half of 6 is 3, which is why one should just say something. Because the signs are the same, of course, it'll be a +3. So the y-intercept is just a positive 3. What do we need for a 2 on this thing? Let's see. Factor, find its zeros. That's a problem because I gave you the factor version. So these zeros here is part of the answer. And then they want you to sketch a graph. Here it comes. Oh, that's a lot. Hey, because I want to say out loud where we're going to put dots on this picture. Let me put some numbers. 1, 2, 3, 4. 1, 2, 3, 4. Oh, I feel so bad. 1, 2, 3. 1, 2, 3. Negative 3. 1, 2, 3, 4. All right. Can someone tell me one place where I'm going to put a dot on this picture on the ground floor, on ground 0? In other words, what are my roots? This is what I'm asking.
Oh, negative 3, 0.
Negative 3. There's one of my roots. That's another root, somebody.
2, 0.
Yeah. Roots, the x-intercept ground floor.
Negative.
Yeah, that negative 1/2 for the purpose of this would go here. So I can see if I'm not here. You know, here's a real question. Look, I see if you want to ask anything. This is one of the tougher sections. You can't use decimals on this. Because if you did, it would just give you the picture and you would just sketch it in. So this one, it doesn't make any sense to use decimals because the point is, could you get your zeros and sketch them? And again, the real deal, you're just supposed to have this equation, turn this thing into this thing, and then go to work. But I hadn't taught that, and I'm like, okay. Dude, just give them the factor form, let them do the thing that we've done a million of. Last one, I'll pause. Anybody want to ask anything like about any of the numbers? Like, where did you get those 3s from? Why'd you put zeros after the numbers? Why'd you get the 3 on to the y-intercept? Just take the numbers that are inside next to the x. And you multiply them by each other. You know what? It worked out this time, but technically, you just use a positive negative 2 and a positive 1/2. In any case, if you get most of this stuff and you try and draw something, I'm giving you a 2. Did I record that? Perfect. I'm still planning on doing it. Even if the thing goes viral. But if it goes viral, then in the sense that we didn't do a lot of these, we gave you the formula, there's a bad boy and the whole thing. To do this one, step 1, you have to move the 12 over. When you do it, it gets the opposite sign. Now, I don't know at what point you saw this in life. You had to see it somewhere. It's the famous formula. So I shouldn't apologize that much, but students usually don't hear teachers apologize, so I do that so that some students feel like, yeah, finally, some teacher knew they messed up, and they apologized. Look how easy I write that. You see how easy I write that? That's like a reminder for you guys. If I teach you guys a life lesson, whatever's hard for you now, if you keep doing it, it will eventually become that easy. It's a beautiful thing. Even if it's math, right now, which I shouldn't because it's time, but let's say I was doing the letter A. Now, no, on the board it's not going to look like the letter B, but those are the strokes. If I'm doing B, no, it's not going to look like it. If I'm doing my name, even though it's not on the, it doesn't have the thick and thin, but look how fast he's doing it. It's not like he's not even like, and that's good enough to be like, what? Sometimes on the weekend, I get my kids and my wife, we go tagging on houses. You know, we do like some Old English. Old English is why you kind of learn it so that you, in Old English, you just, once you know the regular kind, you just square it off. And then, let's see if am I done? All right. So the point is, you know, whatever you're learning, eventually will become easy. The rule in life, though, is something that's already easy for you, go down that road. If something seems kind of easy for you, then go down that road instead of choosing something that's hard and then going down that road. All right, here we go. Put it in, Thomas. A is a -1, B is a -5, and then C is -12. Somebody can help me with the calculator. So the B's. I recommend that you do the parentheses thing as well, so that when you plug in the stuff, it's not hard to do. For those who can't tell, if there's not a number in front of a letter, that number is a 1. In this case, it's a -1 because of the minus sign. That's A, B. That's weird. I just wrote the same numbers below it. You're supposed to be a B. You're supposed to be a C. Get ready for B. You are a -5. -5. -5. A, what are you? You're a -1. And then C, you're a 12. -12. All right. See this part? Some people did this, and then I wanted to give them credit, but I got to get an I out of it. If you can't get an I out of it, then we can't do it. All right. So let me finish this one. Have you look at your thing for 2 minutes. Look at your test for 17 minutes, and that's not enough time. So what's going to happen from there? Monday, I got to do some new stuff. In the second half to finish it. Next week is week 4. I need some of you to do something today, tomorrow, Friday. But then what if a person can't do it until Monday? I'm not sure, but let me do stuff. Oh, so it's a negative then. All right, so 5 plus or minus 25. What are you? You're 48. -48. Is that a 23 that's going to wind up inside that house?
Yeah.
All right. It's the -23 I'm trying to get to, because this is the big deal. Hey, what do you do if there's a negative inside? You just write the letter I out front with that. Put everybody else in black and put that I in red so they can see the big deal. Some people have tried to break it down. For this time around, don't break down the inside. Just let it be what it is, a negative whatever number. And then, and I say you divide into 4s and stuff. Not this time. I appreciate it. I didn't do it long enough. Take a look at that answer.